So first off, let's work on the definitions of acceleration and write down these equations. Acceleration is just any change in velocity. Okay. So we're going to be using these equations to calculate the acceleration or the change in velocity or the time or the displacement of an accelerating object. So sketch these things in your notes, and then we will move on to actually using them. So first practice problem you have. These are going to be the exact same problem-solving skills that we have used in the past, where the first thing I want you to do is to read the problem and write down the things that are given. So a couple things that we know. Frank is sitting at a stoplight in his car. All right, he's at a stoplight. So that means his original velocity, his initial velocity, is 0 meters per second. All right. Light turns green. It takes him 15 seconds. That is a time to reach a velocity of 60 meters per second. And that's his final velocity, 60 meters per second. So that's the original part that you know. We're asked to find the acceleration. So it's an acceleration. Well, I have these three things: initial velocity, final velocity, time. If you look back at your equations, the only thing that can solve for acceleration with those are the final velocity minus the initial velocity over time. We plug them in. And then we come up with an acceleration of 4 meters per second squared. So let me take a moment to talk about units. So looking back at the units here, you had meters per second on the top, and then that's divided by seconds on the bottom. Okay, let me rearrange that. Meters per second divided by seconds. Well, in fractions, if you're going to divide, we have to flip and multiply straight across. Well, that gives us meters. When these two do not cancel, they actually combine. So that's why we get meters per second squared, or sometimes you'll see it as this, meters per second per second. Both are the same thing. Okay? All right, let's go to the second one. So I want you to do the exact same thing here. Write out what you know. Give me the equation. Solve it by showing your work. And then I'm going to do the same thing. Go ahead and hit the pause button. And then see if you come up with the same thing that I do. Ready? Hit the pause button and do it. So we have an initial velocity of 60 meters per second. Then as the deer jumps out and slows down, all right, to a stop. So that means the final velocity is 0 meters per second. The time it takes to do that is 6 seconds. Again, we are asked to solve for the acceleration. It's going to be the exact same equation. Vf minus V0 over t. So it looks a lot like the last thing, but watch out, because a lot of students do this in their head and come up with the wrong answer. All right, they do 60 minus 0. Watch it. It's final, which is 0, minus the initial, which is 60. So it really should be a 0 meters per second minus 60 meters per second over 6 seconds. That gives you a negative 10 meters per second squared. Let's go again. All right, again, go ahead, give this one a try on your own. Write down what you know. Write down the equation that solves for what you're asked for, to solve for, and then solve it, showing your work, and circle the answer. Go ahead and pause it, and then unpause it when you have your answer. So here we go. Initial velocity is 30 meters per second. Final velocity, 70 meters per second. And the time it takes to do that is 20 seconds. So, again, let's ask for acceleration. This will be the last time we actually use this equation. Just want to give you some different examples of it. Vf minus Vo, all right, over t. So acceleration is 70 meters per second minus 30 meters per second over 20 seconds. All right, so that gives you an acceleration of 2 meters per second squared. Let's change it up a bit now, because we've been solving for acceleration. We want to solve for something else. All right, go ahead, pause it, work through your steps, unpause it when you're ready. All right, so we have that. We have an acceleration now of 8 meters per second squared. We also have a time. Now, really important, since we have seconds here, we're going to choose the 60 seconds, not the minute. That way our units can cancel. 60 seconds. All right. We are asked how fast. That is a velocity question. So velocity is acceleration times time. All right, and let's see here. So we are going to then solve for 8 meters per second squared times 60 seconds. All right. Now, if I'm going to show my cancellation of units, that seconds cancel out with one of those. So we know our unit's going to be meters per second. So the velocity after 8 seconds or 60 seconds of acceleration is going to be 480 meters per second. Change it up a little bit more. Looks the same, but this time I'm asked to solve for how far. Go ahead and pause it, work through it. Here we go. 8 meters per second squared time 60 seconds. Displacement, which is a how far, 1/2 times a t squared. So 1/2 times the acceleration of 8 meters per second squared times 60 seconds squared. 14,400 meters. All right, so number 6. Let's take a look at this. So a couple things that we have here. We have an acceleration of 8 meters per second squared. And we know that the rocket travels for a distance of 10,000 meters. So his displacement, 10,000 meters. I am asked to solve for how long it will take for something to happen. So that is a time question. And we have this weird equation, 2 times the displacement over a, and take the square root of that. So 2 times 10,000 meters over 8 meters per second squared. Time works out to be 50 seconds. And one final one here. All right, a high-speed dragster can travel a 1/4 mile, so that is a displacement 402 meters in a time of 4.6 seconds. assuming the acceleration is constant, so I'm going to solve for acceleration. And let's see here. Using our equations, that one is going to be 2 times the displacement over t squared Okay, and let's get the calculator out. Oh, we'll call that 38 meters per second squared after a little rounding. All right, those are your 7.